So welcome back to another video of PPS by Jai Bale Academy. So today I'll be discussing week 6 lab programs. Week 6. So the first program is to find all the prime numbers in between the given range. That is, the input will be n. The output is all the prime numbers between 1 to n. That is, if 10 is the input, then the output should be 2, 3, 5 and 7, because these are the prime numbers in between the given range. Okay, so how to start? See here, first of all, when n is given for us, the first task is to fetch all the numbers between 1 to n. So go for this. For I is equal to 2, because 2 is being the smallest prime number. I less than or equal to n, because n can also be a prime number. I plus plus. If you do this, you will get all the numbers saying that 2, 3, 4, so on up to n. Your first task is complete. As you can see, your first task is complete. The second task is, out of all these numbers, you have to print the prime numbers. And the prime number concept is very simple. If the given number p is said to be prime if it is divisible by 1 and itself. Any number between 1 to p, that may be 2, 3, 4, 5 and so on, they should not divide our given number p. If we do this, this is considered to be a this is considered to be a prime number. Okay, let's start. To do it in an easy way, let's use functions. So what you need to do is, in between this for loop, call prime function prime and pass the number I. That is, it takes only one number I. So what it's happening, we are calling prime of 2, then we are calling prime of 3, so on up to prime of n. This will check every number in the prime function. So what is prime function? See here, you need not return anything from the prime function. So write void prime. Okay, not void, let's go for int. Let's write int prime, and how many parameters are we passing? We are passing only one parameter, that is of the type integer. So int prime int I. So what is happening is, we have a number, let's take it as n. So we have a number n. Okay, we have to check if any number starting from 2 to n minus 1, is it dividing our given number. If this happens, this is not a prime number. If in case none of the numbers starting from 2 to n minus 1 are not dividing my number, it's a prime. For example, 5 is my number, check from 2, 3, 4, because divisible by 1 and itself is the conditions for a prime number. So if it is divisible by 2, 3, 4, this is clearly not a prime number. If it was not divisible, it is a prime number. So go like this, take int I. We need a loop here. For I is equal to 2, because that is my starting number. Any number you take, 2 is the starting number. I less than n, because only for n minus 1 iterations, not the nth iteration. I is less than n. I plus plus. This is the same for loop as you wrote here. The only difference is that less than or equal to, here it's only less than n. Check if my given number n, when it was divided by the given number I, that is from 2, 3, 4, when it was divisible, divided by 1 by 1 by 1, was the remainder 0? That is, if we are checking if 4 is a prime number and the starting number is 2, 2 2s are 4, the remainder is 0, this means it's not a prime number. If we take 5 and 2, 2 2s are 4, the remainder is 1, which means the number was not completely divisible. But here, the number was completely divisible. If this happens, write return 0. That's it. Return 0, close the if bracket, close the for bracket. That is, return is used to get out of the function. We got out of the function. This is the case. If 4 was n and when we came into 2, the number was divisible, we came out. If not, after coming out of for loop, that is, let's take the number is 5. When it was 2, I was 2, not divisible. I was 3, not divisible. I was 4, not divisible. Completely a prime number. So come out of for loop and just printf percentage d, print that particular number n and return 0. By this, we will print that particular prime number. We print that particular prime number in the function, and this is the simplest function which is used to calculate a prime number. Okay, the program and the output are given in the document. You can go and check there. So the next program is Fibonacci series. One second. So the next program is Fibonacci series. So first let's understand what is a Fibonacci series. Talking about Fibonacci series, It's a very unique mathematical sequence where the first number of the series is 0, it is fixed, and the second number is 1, which is also fixed. Okay, and if you want to calculate the next number, that is this particular location, this is nothing but sum of previous two positions. Previous two, that is, if this position you want to calculate, previous one is 1 and this is 0, 1 plus 0 is 1. Okay, and if you want to calculate here this particular position, this is also sum of previous two numbers, that is 1 plus 1, the answer is 2. If we go on up to like that, if you want to find the nth position, let's say nth digit, what does this mean? This is nothing but sum of n minus 1th position, that is if this is n, this is definitely n minus 1 plus, and this will be n minus 2. Okay, this is the logic to calculate Fibonacci series. If this part is clear, n minus 1 plus n minus 2, let's go forward. If you see here 0 and 1, 0 and 1, take it into an array. Let's take it into an array where a of 0 is initialized by default to 0 because that is my starting element. A of 1 initialized to 1. Is it clear? Is it clear? So now let's say there are n number of positions I want to calculate. If this is n, I want to calculate till here. What you can write for I is equal to 2, because a of 0 is already 0, a of 1 is 1. So write I is equal to 2, because this particular position, which is a of 2, is unknown for us. So I is equal to 2, I less than or equal to n. You can go for less than or equal to n or less than n. It's your choice. I plus plus, I plus plus, I will go for less than or equal to n minus 1 position. So I less than n. It's simple. If your array name is a, then write a of I. Okay, a of I, that is my ith position value you want. A of I is equal to, what is this position? This is nothing but I minus 1. As you wrote here n minus 1, this is I minus 1. So a of I minus 1, if a of I is 3, then a of I minus 1 is nothing but 3 minus 1, that is equal to a of 2, which is correct. Plus we need one more position previous to two numbers, that is a of I minus 2. If a of I minus 2 is nothing but 3 minus 2, that is a of 1. As you can see, a of 3 is nothing but a of 2 plus a of 1. Clear? If you do this, complete. We will calculate all the Fibonacci series in just one statement. For I is equal to 2, I less than n, I plus plus, a of I is equal to a of I minus 1 plus a of I minus 2. After that, to print it, just go for I is equal to 0, start from these two numbers. Even these two numbers are to be printed. For printing, I is equal to 0, I less than n, I plus plus, which will print all the numbers from 0 to n minus 1 position. You just have to write printf percentage d, give a space and write a of I. That's it. Return 0, close. So this will be your program to calculate Fibonacci series, where you have to take only one input n, like how many numbers you want to print, and by default you have to initialize a of 0 is equal to 0, a of 1 is equal to 1, and you can start executing. Okay, the complete program and output is given in the PDF file. You can go there and refer to it. I have added the link in the description if you want that manual. Just go and check it. Okay, the next program is to write a program to find GCD and LCM of two numbers using functions. It's a very simple program. Just give me a second. Okay, first of all, let's understand what is GCD and what is LCM. This is 5th standard mathematics. I'm very bad at maths. I have failed in M1, M2, M3, M4, but I'll try to explain. So just stay focused. See here, if we have, let's first understand what is GCD. Let's say I have a number 20. Okay, first tell me what are the divisors of 20. A divisor is a number that can divide the given number. 1 can divide 20, 2 can divide 20, 4 5s are 10, 20, 5 4s are 20, 10 2s are 20, 20 1s are 20. Okay, these are the divisors of my number. Let's take there is one more number 10. What are the divisors of 10? 1, 2, 5 and 10. This is nothing but divisors. Now let's see CD. CD का मतलब होता है common divisors. This means common divisors. That is, if two numbers are given, what are the common divisors? You can see here, 1 is a common divisor, 2 is a common divisor, 5 is a common divisor, and 10 is a common divisor. Okay. Now what is G? What does G stand for? G stands for greatest. That is greatest common divisor, which is the highest common divisor for both. That is 10. So GCD is equal to 10. Okay, GCD is equal to 10. And we have something called as LCM. LCM, I'll tell you what is LCM. LCM is nothing but, see, if you have a number 20, if you have a number 20, write the multiples of 20. 21s are 20, 22s are 40, 23s are 60, and so on. It never ends. Even for 10, write the same. 10 ones are 10, 10 twos are 20, 10 threes are 30, 10 fours are 40. Okay, these are called as multiples. Now common multiples, what are common? Here 20 is common, here 20 is common, here 40 is common, here 40 is common, 60 is common, if you go here 60 is common, 80 is common, it's 80 is common, it's so on. It never ends. It never ends. For that, we don't find the greatest common multiple, we find the least common multiple. And what is the least common multiple? 20 and 20. So LCM is equal to 20. Okay, and now if you have understood how to find GCD, for LCM we have a formula. LCM is equal to the given number A into the given number B whole divided by GCD. That is, my given number A is 20 and my given number B is 10. If we divide it by the GCD that we occupy 10, 10 gets cancelled, we get LCM as 20. As you got here, we got it here itself. Okay, so please by heart this formula. LCM is equal to A into B by GCD. So now I'll tell you how to calculate GCD. For that, as they have told, we should use it using a function. So just imagine this is my main. This, your full program is in PDF. If you want, you can refer that PDF. You are taking input for G. Sorry, you are taking input for A and you are taking input for B. Initialize one more variable int G to store the GCD. Now call the function G is equal to GCD of A comma B. This is first thing. This is first thing. Okay. Now understand what happens. See, GCD, we are returning something. Okay, it's int GCD of how many parameters? 2 parameters, int A comma int B, int A comma int B. Okay, and let's see the two numbers are A is equal to 10 and B is equal to 20. A is equal to 10 and B is equal to 20, and the most least common number, least number that can divide any number is 1. Please understand this. Any number which can divide any given number is 1 and not 0, because see here, 10 by 1, 10, so yeah, yes, sorry, 10 and 1, 10 tens are 10, the answer is 0. Okay, if you take the least common number as 0, that any number divided by any given number is 0, then 10, even 0 tens are, the answer is still 0 and we get the remainder as 10. Okay, so the least common number that can divide any given number is 1. So come here, start a loop, int I comma G, where I is nothing but to check all the numbers 1, 2, 3, 4. We need all the numbers to see what is a common multiple, and we need G to store the GCD. And understand second thing. Understand second thing here. See here, for GCD, the maximum number that can divide any given number, any given two numbers, is nothing but the lowest of these two numbers. The maximum. It may be not possible, but 11 can never divide 20, right? 11 can never divide 20, but 10 is the maximum possibility that it can divide 20. Possibility, I'm just telling possibility. It will divide or not, it doesn't matter. But any number, if we are taking 12, 11, anything more than 11, that is 13, can never divide 12. Okay, I'll put it in very simple words. See here, there are two numbers, 20. Okay, the maximum number that can divide 20 is 20, possibility. And if there is one more number, 10, the maximum number that can divide 10 is 10. Okay, now since it's common, that is GCD, it's common, so 11, if we cross the number 11, 10 can never be divided by 11. 10 can never be divided by 11. So first you have to understand that you have to identify the smallest least of these two numbers, that is int n. Identify the smallest number. N is equal to, if A is less than B, ternary operator, question mark A colon B. That's it. What this does is, n is equal to, there is 20 less than 10, question mark 20 or 10. What happens is, it will check the given condition. Is 20 less than n? The condition is false, so it will execute the part after this colon and 10 will be copied to n. If it was 10 less than 20, then the condition is true. This particular location would be copied to n. Okay, I'm just finding the lowest number between the two numbers, because if we cross the lowest number, the other number can never divide the given number. So wait 1 second. Okay, let's start. We got the smallest number between 10 and 20. Write the for loop like this. For I is equal to 1, because any number given divides the given number is 1. I less than or equal to n, because 10 can also divide 10. I less than or equal to n. I plus plus check if the given number a is it divisible by I. That is, my given number 20, is it divisible by 1, because initially I is equal to 1. It's true. This makes it as a divisor of a. You also have to check, and we have one more number, is b also divisible by I. B mod I, is it also equal to 0, because you have to check if 10 mod I is equal to 0. Is it true? Yes. This means it's a common divisor. So now write g is equal to I. Done. Next time I is 2. 20 mod 2 is also equal to 0. Next 10 mod 2 is also equal to 0. This is also a common divisor, but you can check here. 2 is greater than 1. 2 is already greater than 1. So we are copying it again. So g value was initially 1. Now it is 2. Are we incrementing the numbers? Are we getting the greatest divisors? Yes. We'll go up to 10. That is 3, 4, 5, 6, 7, 8, 9, 10. Final number will be 10, which will also divide 20, which will also divide 10. So we will get g as 10, which is the GCD. After that, printf percentage, that is GCD is equal to percentage d, and print the variable g. Return. You have to return the value of g and close. You are returning the value of g because here now you have to call the LCM function. Clear? We are returning g, and here you can write. Here you can call the function LCM of a comma b comma the value of GCD. As I told, the formula is straightforward, and in the LCM function, write like this: void LCM, take the three parameters int a comma int b comma int g. You can directly write printf LCM is equal to percentage d, and write the formula a into b by GCD, that is g. Done. This will be your program to find GCD and LCM using functions. Just understand this concept. First, the given number should divide the first number. It should also divide the second number. Then it becomes common divisor. Since I am starting from I is equal to 1 to 10, so as we progress forward, the number keeps on increasing. So final number that you have in G itself is the GCD. And the program and output is available in the PDF. Please go there and refer. Jai.